And then I need to share this screen.
I'll take y'all 50. I ain't take mine, dude. Not doing it out there. I want to retwist. Look all this was. So, you ain't have to take them? No, take them off. Well, I mean, I know that tomorrow.
All right. All right, so here's what we've got going today. Let me hide that. All right, so we've talked about different ways to write equations. Today, we are going to talk about solving systems of linear equations in two variables. So basically what that means is we're going to have two equations of lines. All right, and basically we need to find out where these two lines cross each other, where they intersect. That's basically what we're doing. We're going to talk about three different ways to do it. All right, based on how the equations are set up, we'll determine what's going to be the easiest. Guys, I can't talk over y'all the whole time now.
My bad, it was my fault.
You good, we good. I just don't do too many teaching, so I don't want y'all to miss. All right. So, move on. Two linear equations are called a system of linear equations or a linear system. A solution to a system of linear equations in two variables, an ordered pair that satisfies both equations. So our answer on these, you could think if we have two lines that cross each other. So let me pull this up. So if we have a coordinate axis and we have a line here and we have a line here, what we're looking for is this spot right here where they intersect. And we're going to name that this one 1, 2, 3. Say that's the point 3, -1. So this is what we're looking for. And one of the ways that we can do that is by drawing the graph. Now the problem with the graph is if the lines intersect in somewhere that's not a whole number, it's like a fractional number, you're not going to be able to see it on the graph. Okay? But that's basically what we're going to be trying to do. Okay? Now, the first thing they ask you to do, though, is to sort of work backwards. They start with the two equations. So the first few problems on your assignment, let me write this down on my whiteboard. They want to know, is the point 1, 2 a solution to this system? Well, for it to be a solution to the system, that point 1, 2 has to be on both of those lines, which means if I substitute in, remember this is in X, this is a Y, all right? If I substitute into each equation for the X and the Y and it checks out for both equations, then that's a solution. If it checks out for one of them, all right, if we have two lines here, if it checks out for one of them but not the other, that means it's like that point right up there that's not the point of intersection. It means it's on this line but not on the other. We're looking for the point of intersection, which means it is on both lines. So that means it's going to satisfy both equations when I plug in. So all I have to do here is I take the first equation and I plug 1 in for X and I plug 2 in for Y. And I need to know if that equals -4. So this part now you can just punch in your calculator. It's actually 2 minus 6 equals -4. That is -4 equals -4. That checks out. So we're halfway there. I know it's on that first line. Then I'm going to take the second one do the same thing. 2, 1 in for x. I'm going to put 2 in for y. Does that equal 4? 2 plus 2 equals 4. 4 equals 4. Checks out. It checks for both of them. So yes, this is a solution. If it checked for one and not the other, so if you're working either one, if you plug into the first one and it doesn't work, you don't even need to plug into the second one because you've already got your answer. It has to work for both for it to be an answer of yes. For it to work for both, that means it's on both lines. If it's on both lines, then it's the point of intersection. Okay? So that's the first thing you'll be asked to do in your assignment is just tell me, is this point on that line or is it the intersection point or not? All right. Now, the next thing we're going to do is I'm going to show you 3 different ways to solve these problems. Okay? And really, because of the way our class is set up, right? It's all on the computer. For the most part, you just got to get the answer. If there's one way that you can do really well, I would work that way every time that you could. One of these ways you may like better. Now, sometimes it's easier with certain types of problems than the other. But I'm going to show you 3 ways. The first way really shouldn't be any problem at all. It's just graphing. So it's asking me to solve by graphing. So it's got the 2 equations, x plus 2y equals 2, and x minus 2y equals 6. So you can graph the 2 lines however you would like. If you want to graph by x and y intercepts, I suggest what I always do is I just put it in slope-intercept form. Because to me, that's the easiest way to graph. So I'm going to start with this one right here. X plus 2y equals 2. To put it in slope-intercept form, I subtract x, and I get 2y equals negative x plus 2, and then I have to divide everything by 2. So this is stuff we've already been doing. So y equals negative 1/2 x plus 1. So what's that tell me? My y-intercept is 1. My slope is negative 1 over 2. So I got to go down 1 over 2, and then there's my line. All right. Then I'm going to take the second equation, and I'm going to solve it for y. So I would subtract x. Negative 2y equals negative x plus 6. Divide by negative 2. I'll get y equals 1/2 x minus 3. Make sure you get your signs right. So this one means the y-intercept is negative 3. 1, 2, 3 is right here. The slope is up 1 over 2. And then there's a line. Now, here's the problem when you're doing this by hand, which you won't have to do it by hand on your computer. It'll have a grid for you, so it'll be exact, is I have to figure out what point is that exactly. And it looks like it is at 4, negative 1. Now, the way I could be sure is I could plug in 4, negative 1 into both of these. 4 minus 2 is 2. 4 plus 2 is 6, so that is what it is. Now, on your computers, you're not going to have to worry about that as much because you will be able to tell. All right, it's not going to have it floating around in the middle where you can't tell where the point is. Okay, but the whole skill of this revolves around you being able to graph an equation. Now, if you have a graphing calculator, right, you've got it. If you can get it equal to y, then you can put it in the calculator. Okay, but that's all solving by graphing is you graph both lines on the same coordinate axis and you tell me where they cross. Okay, so that's not very that's not very difficult, especially if you know how to graph a line. It becomes very simple. Now the problem comes, and the reason we can't do this all the time is, let me draw, let's say I had a line that went right through here, and then I had a line that went like this. Now, you see how that point there, it's just sort of floating in there in between -1 and 1. It's just, I can't look at that graph and give a very good, all I could say that's about a half and a -1/2. But this is the problem with solving by graphing, is if it is not a nice clean number, you can't figure out what it is. Now the calculator, the graphing calculators, there is a button where you can still get it, but you're not going to be able to get it in fraction form. It's just going to be a decimal, and sometimes you need to know the fraction form. So there are two algebraic ways to solve these, and that's what we're going to spend the rest of our time on. It's a little bit more difficult. But we can handle it. All right, so that's a little tough to see. Let me see if I can figure out how to. I thought it had a way to make that bigger. Nope, maybe not. Maybe I can't make that bigger. Or if I can. Nope, I don't think I can. Zoom, 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 marquee zoom. There we go. All right, so there's two ways to solve algebraically. One of them is called by substitution. And we're going to talk about 3 steps in order to do this. All right, and this is not going to make a lot of sense to you just reading through or listening to me talk through this. You have to actually do it, but I am going to write the steps down so we can refer back to them. So step 1 is to solve one equation for one of the variables. So you're going to have an x and a y in both equations. If you just have an x in one equation, then that's what you'll solve for. All right, but generally speaking, you'll have an x and a y in both equations. Well, you got to solve one of the equations for either x or either y. That's step 1. Step 2 is you substitute that into the other equation. That's step 2. And I forgot to add and solve. You substitute into the other equation and then you solve it. Step 3 is take step 2 solution and sub it into step 1 solution, is how I'll say it. So in step 1, we solve for one of the variables. So step 3 is to take what we get in step 2 and substitute it into that equation we solve for in step 1. Okay? And then they say to check. I don't really care if you check it or not. You want to be, okay, now how do I get out of Zoom? Just going to keep zooming. There we go. All right, so here is our first equation. All right, And notice they put that little bracket. That's sometimes you see that bracket, sometimes you don't. That's just to show you that these two equations are together. All right, so let me pull it up on the whiteboard here. All right, so I've got our three steps up there. All right. Now, what this is asking for is it wants to know where these two lines intersect. Okay, but we're not going to solve it by graphing. We're going to solve it by substitution. So step one says to solve one of those equations for one of the variables. So what I have is I've got an x. I've got an x in both equations, and I have a y in both equations. And what I have to do is I have to pick one of those two equations and get that x or that y by itself. All right? Now, the nice thing about this one, if you look at the first equation, it already has y by itself. So in this particular problem, step one has already been done for us. So step one, already done. The y is by itself on one side of the equal sign. So we're ready to move into step two. All right, step two says you take the other equation. So I'm going to take the equation I have not used yet, which is 4x minus 3y equals 24. And then because I have y equals here, that means negative x minus 1 is equal to the same thing as y. So whatever variable I have right here, I'm going to go to this equation, and I'm going to take that variable out, okay? And I'm going to put in what it's equal to. So I'm going to take 4x minus 3. I'm going to take out the y. Notice everything's the same. I'm going to take out the y and put in what y is equal to, is negative x minus 1. Then you have to simplify and solve it. So I've got to distribute. So I'm going to have 4x plus 3x plus 3 equals 24. 4x and 3x add to 7x. 7x plus 3 equals 24. Subtract 3. 7x equals 21. And divide by 7, which is a little tough to see on there. Let me see if I can scoot this up a little bit. All right. And 21 divided by 7 tells me that x equals 3. So my solution, I know the x coordinate is 3. Then the last step is the easiest step. Step 3, I take that number I just found, I go back to step 1, the end of step 1, and plug it in. So I'm going to put a 3 in for that x. So there's that x. So I'm going to put in a 3. Negative 3 minus 1 is negative 4. So there's my solution. 3 comma negative 4. All right, a lot of steps through that, but if you get the pattern of it, it's not that difficult. All right. And
Can you leave that up there?
need to see it for a minute.
No, I was talking about when we started working.
You can take a picture of it because I got to go on. Or it'll be on the video too on the online. You can skip ahead till you see it.
That's probably what I'm going to do.
All right, that'll work. Okay. Actual size. Where's the one we just did? We just did that one. All right, so here's another one. Write this one down. And then I'm going to go ahead and erase these instructions up here so I can have more room to write. And let me see something real quick. I may have divided this into 2 lessons. I don't know. I think I looked at that earlier today. This is chapter 5. Yeah, okay. I didn't. So we got it all this once. All right, so here is our problem. So first step, step 1, is we got to solve for either x or y in one of the 2 equations. Now, this one doesn't have an x or y by itself, but what you want to look for is you want to look to see if any of those 4 variables have the understood 1 in front of it. And there is one variable that has the understood 1 in front of it. If I will solve for the one, or if there is one that has an understood 1 in front of it, it makes it easier because it just takes 1 step to solve it. All right. If I was going to solve for the x in the bottom, I would have to get rid of 5y and then divide by 4. When I divide by 4, I'm going to create fractions. Since there's just an understood 1 in front of that x, I'm not going to have to divide. So I'm going to take x plus 3y equals 5, and I'm going to subtract 3y is all I have to do. So I get x equals negative 3y plus 5. All right, that's my step 1 result. All right, step 2 says I take the other equation, which is 4x plus 5y equals 13, and I'm going to replace one of these variables with what I just solved for. Well, I'm going to replace the x this time because I got x equals. So I can take out the x. Everything else is going to be the same. And I'm going to replace it with negative 3y plus 5. Now it's basically the same thing. You distribute negative 12y plus 20 plus 5y equals 13. I combine any like terms over here, which negative 12y and 5y need to combine. So that's negative 7y plus 20 equals 13. Now it's just an easy 2 steps. Subtract 20. Negative 7y equals what? Negative 7. Divide by negative 7. And I get y equals positive 1. Step 3 is to take that what I just found and plug it in for that variable, for y. So that's going to be negative 3 plus 5, x equals 2. So my answer, x, y. That's where those 2 lines intersect. zoom in on that a little more. All right. All right, let's look at another one. All right, negative 4x plus 5y equals 9. Negative 2x plus y equals negative 3. All right, so the first step, step 1, I want to solve for either x or y. Remember, I look for a variable that has an understood 1 in front of it. That has a negative 4, that has a 5, that has a negative 2. This is the one that's set up like I like. And why is that not? What's going on? Did I pause something somewhere? Did I lose? Oh, I must have lost internet connection or something. What's going on? What's going on? What's going on? Technical issues, of course. Let's see if that clears up. Yeah, well, you gotta go to the bathroom 2 times every day. Check it out. Bring back some toilet paper, or I'll get some toilet paper too, and you can just step out in the hall. Yeah, but just make sure you check out right there. You gotta scan that top one and fill it out. All right, sorry, people at home. We have, well, the people at home can't hear me because you're not on Zoom anymore. What am I trying to talk to you for? Hey, there we go. I can really see how bald I am right there when I take a look at my head. Well, we've lost internet. I bet that's going to mess up my recording too. Not. Unable to connect. I don't think I did anything to turn off my internet. I don't think there's a button. Do I have internet on this one? This ain't even going to do anything.
You gonna see it. They like contact ash, but that's how
Well, that's logging in. I guess I need to pause my video.